Hello viewers. We'll introduce to the vector integration. Firstly, we represent a vector a of t equal to ti plus t square j plus t cube k, where I, j and k are the unit vectors according to the x, y and z axis respectively. What represent this vector? Firstly, we will see in 2D for more illustrating it. So let's go place. Let be a vector equal to ti plus tj. Firstly, we will see the graph of this vector, and let's go the very simple vector phi vector equal to 2I plus 3z. If we put this vector, that is the x-axis and origin and y-axis, then 2 3 be the point, and p and op is denoted by vector. This is the op vector. So p vector equal to 2I plus 3z. If q vector equal to such types, that's 4I plus 3z, the coefficient of I is sensed, but coefficient of j is unsensed. Then putting this vector in this graph, we can find this is the OQ vector. That means 4, 3. The terminal point of vectors joining, and then we get a straight line. We will assume there are 2, 3, 4 and etc. Then we get this straight line. So we can say that if p vector equal to ti plus 3j, then this vector represent a straight line, and p vector in terms of t, so vector valued function. So this is the straight line. Similarly, if b vector equal to ti plus t square j, then comparing with a very simple vector, that's xi plus yj, that is p vector. Then comparing its x equal to t and y equal to t square. That means x of t equal to t and y of t equal to t square. So y is a function of t and x is a function of t. This is the parametric equation of parabola. So we can see the figure of parabola. This is the equation figure of parabola. So we can say that the b vector is a parabola. Similarly, a vector is a curve, but first types of curve which is presented by the 3D graph. So we put a figure to visualize this curve. Now this a of t is the vector which represent the 3D curve. We will see the curve in a 3D shape. For seeing this in 3D curve, look at place. The euro curve is the graph of and when t cube that means the coefficient of k is absent, then this is shaped as a parabola, and in xy plane. When t cube is present, then for the t cube, that means z equal to t cube, the graph is in the shape. So we can say that the one parameter is present there, then this is the R. So in general technique, we can say that the A of t vector equal to a1 of ti plus a2 of tj and a3 of tk. These are the curve. Always represent a curve. Is it clear? Now we will see that's another types of vector. Suppose a of x, y, z be a vector, that is the coefficient of I is also a function of x, y, z, and similarly the coefficient of z is also a function of x, y, z, and similarly the coefficient of k is also function of x, y, z. Then what represents x? Where a1, a2 and a3 are the function of x, y and z. If a1, a2 and a3 are function of only t, then this is the curve. So let's go. If y and z constant, then this is the function of only x, then it represents a curve only. For any values of z, this is the curve. So the another values of y is another curve, another values of y and z, this is curve. So if we assemble a such types of curve, then we see that this is a 3D shape. That means surface. We will see some types of surface from example, which is the 3D curves. So interesting, and we will see some 3D curves to illustrate this example, like as this, and another figure will be shown in the right side of this board, and these two figures will be illustrated this illuminated term. That's there are many curves on the surface. When y and z be the constant, then it means that say one curve on the surface. Y and z is constant, that means x, y, z are variable or parameter there are, then this curve in a plane that side. But when present the z, there is ups and down to be clear by the z. So when a vector is written of a function of x, y and z, then this is defined a surface. Now we will see the ordinary integral of a vector. That's a very simple terms. That means a of t, that means a is a function of t, and a1 t I plus a2 of t j and a3 of t k. This is a vector, and this is also a curve. So if we integrate this vector, then we can find the a of t dt equal to integrate a1 t dt I, that's the unit vector, and j a2t dt plus k a3t dt. So easy. Thus that a t equal to ddt of mt. So when we integrate a of t, then the result is mt, and the integrating constant c. When this is definite integral, that means a and b with the limit, a is the lower limit and b is the upper limit, then this is not necessary. Neat. That means ab. So we can write that m of b minus m of a. So it is for definite integral. Let's go please an example, very easy example. R of t, r is the position vector, dt square minus ti plus 2 minus 6t, this is the coefficient of j, and plus 4k. If we find the integration, that means r of t dt, then the result is very simple. The coefficient of I is integrated. That means t cube minus t square by 2i, and 2t minus 3t square j plus 2t square k. Very easy. When we find the definite integral, that means 0 to 2, the limit, then the result 0 to 2. So putting these values, and we get very simple answer. Then 2, that means 8 minus 2, that means 2, and r. 2, that means 4, and here 12. So 4 minus 12, and that is the same. Similarly, 2, that means 4, 2 into 2, that means 8. So this result is 6i minus 8j plus 8k. Thank you very much.